Hey guys, so this next one we're going to be looking at the idea of dividing radicals. So if you look on the first page of your notes, you guys notice you have a diagram that looks like this. We're trying to show why the square root of a over b is equal to the square root of a over the square root of b. So one of the things that I know, based off what we've been doing, is I can rewrite any square root as a rational exponent. That is a 1. That's a 1/2. I can rewrite that root as a rational exponent. So knowing that, then I can take this rational exponent and break it up into a to the 1/2 over b to the 1/2. And I'm just using the power of a quotient property. That basically tells me that I could take 1/2 to the a and 1/2 to the b. Then, using what we've been doing, I could take a to the 1/2 over b to the 1/2 and rewrite that as a root. So just to give you guys an example of one, this is at the bottom of page 1. I'm using, I got the square root of 25 over 49. So based off what we just talked about, we just proved that we can do this into that. I can say that the square root of 25 over the square root of 49 is equal to 5 over 7. Why? Well, because the square root of 25 is 5, and the square root of 49 is 7. Here's another way for me to think about this. I can work backwards. If I have two square roots, I can put them together, and then I could say, 3 over 2 is 16. The square root of 16 is 4. So let's look at examples on the bottom of page 2. I got the square root of 16 over the square root of 81. So what I can do is say square root of 16 over the square root of 81. Well, I know that's going to be 4 over 9. Not too bad. Doing the same thing here. I got the square root of 6 over the square root of 25. Now what I know is square root of 6 doesn't simplify, so I'm just left with square root of 6. Square root of 25 is 5. And I'm done. Now let's look at this one. I'm taking the square root of 15 over the square root of 30. And the issue that I run into is 15 is not a perfect square. Square root of 15 is a little bit less than 4. And the square root of 30 is between 5 and 6. So I can't do anything like that because I cannot have any irrational numbers in my denominator. So what we're going to do is do something called rationalizing the denominator. Okay, mathematicians can be super picky at times. When it comes to exponents, they don't like negative exponents hanging around in the final answer of a problem. Well, they have issues with radicals too. Radicals are not allowed in the denominator of a fraction for final answers. We need to rationalize the denominator. Is the process of simplifying the fraction so that the radical is no longer in the denominator. Below are two examples where we would need to rationalize. Right here, I have the square root of 3 in the denominator, which is an irrational number. Here, if I were to break this up, I would get the square root of 5 over square root of 3. Square root of 3 is irrational. It's a decimal that doesn't stop or repeat itself. So I got to deal with that. So here's an example of how someone dealt with it. What they did is they noticed, I have the square root of 2 in the denominator, so how can I get rid of that? Well, there's a rule that talks about the idea that in order to get rid of a radical out of the denominator, if I multiply the top and bottom by that value, I can get rid of it. Why? Well, I can multiply anything by 1, and that's what square root of 2 over square root of 2 is. That's just 1. It's just a different, fancier way for me to rewrite 1. So what I'm doing is I'm taking 3 times the square root of 2, which gets me 3 square root of 2. Square root of 2 times square root of 2 gets me square root of 4. That gets rid of my radical in the denominator, because what is the square root of 4? It's just 2. It works. So let's look at 1. Let's try to work 1 out. In this case, I have 8 over the square root of 5. So in order for me to get rid of the square root of 5, what I'm going to do is multiply the top and bottom by square root of 5. That's just 1. I'm multiplying this by 1, but it's just a different way for me to see 1. So I end up with 8 square root of 5, and then I have the square root of 5 times 5. Well, that's 8 square root of 5 over the square root of 25, and the square root of 25 is 5. So I end up with 8 square root of 5. Let's look at another one. In this case, I have 4 square root of 2. I want to get rid of the square root of 2, so I'm going to multiply the top and bottom by square root of 2. So I end up with 4 square root of 2 over square root of 4. Because that's what square root of 2 times square root of 2 is. That's just square root of 4. So I end up with 4 square root of 2 over 2. Now, I have values that are not underneath the radical sign, so I can actually simplify those. Because I know 4 divided by 2 is 2, and I'm just left with 2 square root of 2. Let's look at one more. In this case, I have 2 square roots, one on the top, one on the bottom. I want to get rid of the one on the bottom. I don't really care about the one on the top. I just want to get rid of the one on the bottom. So I'm going to multiply the top and the bottom by square root of 5. So I end up with square root of 10 over square root of 25. That leaves me with a 5 in the bottom, square root of 10 up top. I can't simplify it anymore because I don't have any other numbers outside my radical sign. What I'm going to ask you guys to do is try the next 3. These are the 3 I want you guys to try to do, and we will talk about them on Monday, guys. Have a great weekend.